Paging a collection with LINQ. How do you page through a collection in LINQ given that you have a start index and a count? It is very simple with the skip and take extension methods. var query equals from I in ideas. Select I. var pagged collection equals query. Skip. Start index. Take. Count. A few months back I wrote a blog post about fluent interfaces and LINQ which used an extension method on iQueryable less than t greater than in another class to provide the following natural way of paginating a LINQ collection. var query equals from I in ideas. Select I. var paged collection equals query. In pages of 10. var page of ideas equals paged collection. Page 2. You can get the code from the MSDN code gallery page. Pipelines. Filters. Fluent API and LINQ to SQL. I solved this a bit differently than what the others have as I had to make my own paginator with a repeater. So I first made a collection of page numbers for the collection of items that I have. Assumes that the item collection is my items. Int page count equals my items count plus page size 1. Page size. I enumerable less than int greater than page range equals enumerable range 1. Page count. Page range contains 1, 2. Page count. Using this I could easily partition the item collection into a collection of pages. A page in this case is just a collection of items. I enumerable less than item greater than. This is how you can do it using skip and take together with selecting the index from the page range created above. I enumerable less than item greater than page range. Select page index equals greater than my items. Skip index asterisk page size. Take page size. Of course you have to handle each page as an additional collection, but e.g. if you're nesting repeaters then this is actually easy to handle. The one-liner TLDR version would be this. var pages equals enumerable range 0. Page count. Select index equals greater than my items. Skip index asterisk page size. Take page size, which can be used as this. 4. Enumerable less than item greater than page. Pages. Opening curly bracket. Handle page. 4. Item page. Opening curly bracket. Handle item in page. Closing curly bracket. Closing curly bracket. This question is somewhat old, but I wanted to post my paging algorithm that shows the whole procedure, including user interaction. Const int page size equals 10. Const int count equals 100. Const int start index equals 20. Int took equals 0. Bool get next page. var page equals ideas. Skip start index. Do opening curly bracket. Console right line page 0. Quote took page size plus 1 for each var idea in page. Take page size. Opening curly bracket. Console right line idea. Closing curly bracket. Took plus equals page size. If took less than count. Opening curly bracket. Console right line next page. N. Quote char answer equals console red line first or default. Get next page equals default. Char equals answer and an y equals char to lower invariant answer. If get next page. Opening curly bracket. Page equals page. Skip page size. Closing curly bracket. Closing curly bracket. Closing curly bracket. While get next page and took less than count. However, if you are after performance, and in production code, we're all after performance, you shouldn't use LINQ's paging as shown above, but rather the underlying IE numerator to implement paging yourself. As a matter of fact, it is as simple as the LINQ algorithm shown above, but more performant. Const int page size equals 10. Const int count equals 100. Const int start index equals 20. Int took equals 0. Bool get next page equals true. Using var page equals ideas. Skip. Start index. Get enumerator. Opening curly bracket. Do. Opening curly bracket. Console. Right line. Page, 0. Quote. Took, page size. +1. Int current page item no equals 0. While. Current page item no plus less than page size and in page. Move next. Opening curly bracket. Var idea equals page. Current. Console. Right line. Idea. Closing curly bracket. Took plus equals page size. If. Took less than count. Opening curly bracket. Console. Right line. Next page. N. Quote. Char answer equals console. Red line. First or default. Get next page equals default. Char. Equals answer and an Y. Equals char. To lower invariant. Answer. Closing curly bracket. Closing curly bracket. While. Get next page and took less than count. Closing curly bracket. Explanation. The downside of using skip for multiple times in a cascading manner is that it will not really store the pointer of the iteration where it was last skipped. Instead, the original sequence will be front-loaded with skip calls, which will lead to consuming the already consumed pages over and over again. You can prove that yourself when you create the sequence ideas so that it yields side effects to even if you have skipped 10 to 20 and 20 to 30 and want to process 40 plus. You'll see all side effects of 10 to 30 being executed again before you start iterating 40 plus. The variant using IEnumerables interface directly will instead remember the position of the end of the last logical page. So no explicit skipping is needed and side effects won't be repeated.